We actually have another session back to back. This time we have the graph and we have Ørjan, who's going to be doing a session on building decentralized serverless applications. I think I saw Ørjan already join. So if you're here, how are you doing, Ørjan?
Hi, yeah, I'm here. I'm doing great. Thank you. How are you?
I'm doing really well, thank you. Yeah, well, do you have a presentation today? If so,
I do. Yeah, in this workshop, we will take a look at how the graph provides critical infrastructure to Web3. And I will tell you a little bit about why I am so excited about the graph. And hopefully by the end of this presentation, you will be just as excited. I am Ørjan Auestad. I go by Slim Chance in Web3. So you can find me on Twitter, Web3 Slim Chance. You can find me on Discord. I hang out in the official graph Discord at thegraph.com/discord, and you can find me there and tag me if you have any questions. And there's also a big section there for questions and support if you are building your first subgraph after this. So a question I very often get is, why do we need index data? The blockchain is public, right? But the truth is, most blockchains are optimized for writing data and not for reading it. And you can imagine the blockchain as a big public library, and every day there comes a new truckload of books, and it's just added to the end of the shelves. And you're limited to browsing the library and look up individual titles. Now imagine you go into that library and want a list of the top 100 books ordered by the word count. To get this list, you will need to search through every single book and find the word count of each one of them, then sort your list, and then serve the top 100 books. But that takes a very long time, and it's not feasible to do it in real time. Let's take a more practical example. Most of you are probably familiar with Uniswap, a decentralized exchange where you can trade tokens. And there's also info.uniswap.org. It's a analytics page that provides valuable data about the exchange. And every time a token is traded, and that can be multiple times per block, these charts need to be updated. And because the price of the token, they change with every single trade. And imagine if you wanted to create these charts just from querying raw blockchain data, you would need to go back in time and query every single block and do millions of calls to an ETH node. And that is not only incredibly resource heavy, which can be read as expensive, and all the load times may even be minutes or hours, depending on how large of a data set you're querying. So this data just needs to be pre-processed or indexed, and that is where the graph comes in. And everything you see on this page is provided by the graph. So who needs index data? And that turns out to be everyone. Over 64,000 subgraphs have been created already with the graph. So that is 64,000 open APIs, or open views into blockchain data. And over 640 billion queries have been served. The reason you want to use the graph is to create a customized API that is tailored to your data requirements. That means if you need aggregated data, if you need any viewpoints from different protocols and you want to aggregate that together, or you want to do some pre-processing, that is something that you can do with the graph. So any kind of rich, sorted, filtered, aggregated data is very easy and simple to do with the graph. And it allows for fully decentralized and serverless application. After all, a dApp that relies on a single centralized server is just an app. So we currently have two services on the graph. We have the hosted service, which is a centralized service run by Node, one of the core developer teams at the graph. And the hosted service currently supports 38 different networks. So we have Near, Polygon, BNB, or Arbitrum, and 35 more. And then we have the decentralized network, and we are currently only supporting Ethereum mainnet on the decentralized network, but we are in the process of migrating network support from the hosted service to the decentralized network. And we believe that every dApp deserves decentralized and open APIs, and that this is crucial to create the robust, secure, and reliable Web3 that we are all wanting. So we are currently doing a incentivized program to increase the support of different chains on the network. So we have started with Gnosis chain, which is now on the testnet on the Graph network, and it will soon be soon be enabled on the decentralized network. And following that, we will also add 1x1 chain in the incentivized testnet that we're currently running. So why do we need the graph to be decentralized? We had a very well-working centralized product. Why would we instead of monetizing that, why are we pushing so hard for decentralization? And to me, the answer is very clear. There's no central point of failure. You never have to call your backend engineer on Saturday evening and say that your server went down, and you're not at mercy of large centralized service provider. It's load balanced. The graph is infinitely scalable and does so seamlessly. As you query the network more, there will be more query fees flowing in. That will prompt more indexers to serve your subgraph, and you will have this dynamic load balancing. It's a geo-distributed service where indexers are implicitly incentivized to distribute their service across the globe. There's censorship resistance. You will never receive an email saying your server was shut down due to the new anti-crypto stance of your service provider. And I'm sorry if I'm pulling off some band-aids there with certain providers shutting down recently, for example, Solana nodes. And that is not something that will happen with the graph. We are distributed, we are decentralized. And last but not least, we are a decentralized network of 160 indexers. This is an old number. We are now at around 240 indexers that are competing to deliver fresh and cheap data with low latency and high reliability. So we already see today that consumers come to us and are very happy with migrating from the free hosted service to the paid decentralized network on the basis of the improved quality of service alone. I'm going to now dive a little bit more into what a subgraph is and how would you create one for your data application. So let's take a look at a subgraph. It has three main components. The first component you will work with is a subgraph manifest. This is where you define your data sources, such as which network are you indexing, what contracts do you want to listen to, and what is the start block of these contracts, when do you want to start indexing, and which events, calls, blocks do you want to listen to. And in the case of non-EVM chains, this could be transaction receipts or other handlers that are defined in the subgraph manifest. Second, you will work on your subgraph schema. This is an overview of the the final PostgreSQL or Postgres structure that you want to store all your data in. So it's a data structure where you define all the entities that you want to store and the relations between these entities. And this is where you want to think ahead and make the subgraph schema as close as possible to the data requirements of your application. That will save you a lot of time down the line. And finally, we have the subgraph mappings. This is where most subgraph developers spend the most time. This is where you are creating the mapping from your events and calls that you have defined in your manifest and into the data structure that you have defined in your schema. This is also where you do any transformation, any aggregation or transformation of the data. So say you want to do time series data, this is then you would do that in the mapping file. Yeah, so that was my presentation. Now we'll dive into how we can build a subgraph in just a few minutes. So let me. The first thing you will do is go to thegraph.com. And in the upper left, you will see the two products I mentioned earlier. The hosted service is the free centralized service that is run by Encode. And you have the Subgraph Studio. That is the staging area for the decentralized network. And we want to create a subgraph on the Subgraph Studio today. So I click on this studio, I connect my wallet. And I sign a message showing that it is indeed me that is signing in. So I have already created some example subgraphs. Let me click on create a subgraph. And today we will take a look at the Bored Ape Yacht Club contract, the BASE contract. Let me call it BASE Encode. But here I select which network I want to index. The BASE contract lives on Ethereum mainnet, so that's the one I will choose. So now we have a page for the subgraph with some information. We can change the image, display name, description, and things. You also have a list of important commands that you might want to run. The npm install global the graph protocol graph CLI. That is what we will be using to deploy our subgraph. I have already done this on my computer. So we can jump directly to the init. This will initiate a boilerplate code for us. So let's do graph init, studio, and BASE encode. That's the name that or the subgraph slug that I gave the subgraph in the beginning. I also recommend that everybody use the cheat code index events. This will create some boilerplate code for you, or some additional boilerplate code for you that will one-to-one map all the events in a contract to corresponding entities in the schema, entities and fields in the schema, and that will make things much easier, and it will give you some code to start working from. So it's an EVM chain, so we choose Ethereum, the subgraph slug. I will just use a default directory, and it's an Ethereum mainnet. So now this will initiate our scaffold, download the API from Etherscan, install the dependencies, and just give it a sec. And then it asks us if we want to add another contract, if we want to index multiple contracts in one subgraph, but we do say no. So, and then we can open this in an editor, and we can take a look at the three files that we talked about earlier. The YAML file is the manifest. This is where we define our data sources, and we see that it's already populated with our contract address and the API. I also want to add a start block here. This is so that we don't check every single block for the first 12 million blocks to see if there's anything happening on this address. We already know that this is I pasted the deployment address of the base contract, and we know that before it was deployed, there was nothing happening here that we need to index. So this just speeds up your subgraph dramatically. So I highly recommend that you remember this step. And if we want now, we can already, this is actually everything we need to do. Like we can now do graph code gen. And then we would do, go back here. We would authenticate our CLI so that we can deploy to this studio instance. I authenticate it. I can recreate that authentication code later on, so nobody uploads any funny subgraphs to my studio. And then I can I had another graph there. And then I can deploy it. So now I deployed simply the boilerplate code. The only change I made was updating the start block so that we don't try to look through a lot of empty blocks. And if I now go over to the playground and refresh the page, you will see that the subgraph has already been deployed. It's syncing. It's on 77% right now. And you can already start to see the all the data that has ever been added to the base contracts. Yeah, that's a good question, Yash. So Yash asked, why isn't the start block included in the boilerplate code? I think that is definitely something that could and should be done. So our graph node is open source, and so is our graph CLI. If somebody makes a PR to include that, I think that would be cool. It could even be just a flag that we set, include start blocks. But yeah, for now it's a manual process of adding your start block, and hopefully we will see a lot more subgraphs than just the boilerplate code. So I think you can make do with adding the start block as well. If I refresh the page, it's and then so this is a boilerplate code with let's see, this is the events that we're looking for. We can look at the schema. This is what we are storing, and we are storing the 4 events that are happening. So it's approval events, approval for all, ownership transfer, and transfer events. And that is pretty cool that we already have all of these stored for that subgraph. But what is really powerful about subgraphs is that you can add any kind of like aggregated or any new data if you want. So you could do, say, you not only want to store the transfers and the ID is the transaction hash and log hash. You don't even you don't want to just store this. Maybe you want to also store a timestamp. That is also a big end, for example. And you can go to the mapping code. So this is where each of these events are taking in an event from the manifest, and it's creating a new entity with a certain ID, and it stores like the POM, the to, the token ID, so it stores the parameters. But it has now that we also have a entity dot timestamp, we can go to event.block the timestamp. That is everything that is needed. Then we can run graph codegen again. And then redeploy it. So we now we can see the first version has been archived, and the second version, we can choose to unarchive it if we want to, and the second version has been deployed. So, and now you can see on the approvals, or was it the transfers? So let me open. We can look at on the right side here. We have a way to construct our queries by clicking on the documentation explorer and the GraphQL explorer, and we can look at, for example, transfers. We can create queries by simply checking the checkboxes. So say we want the first 10 subgraphs ordered by the timestamp in ascending direction, and say we want to from the to and the timestamp and the token ID, for example. So this is how we can like easily construct a GraphQL query. We can even save it as a example query. Now we can choose between the queries that you have saved. Let me see if there's any questions. Yeah, so Yash asks that start block is already added to the boilerplate code. I'm not sure. It could also be just a later release of the Graph CLI that is still in alpha. So, but this is how you would create your own query, your own subgraph. You would then loop back to your subgraph code, make any changes that you want, and then redeploy it to the network or to the studio. Once you if you want to make this a production subgraph, you would also publish it to mainnet, and this would cause eat gas, and you would also need to signal with a bit of GRT. This indicates to the indexers that you intend to use this in a production environment. So this would lock some GRT in a bonding curve. But for now, when you are participating in the network, you can either deploy a subgraph to the studio, or deploy it to the hosted service if you're using a non-Ethereum network. As for the other track, we have two tracks. One is for creating a new subgraph, either in the studio or on the hosted service. The second track is using an existing subgraph. And in that case, you would either go to the Graph Explorer. Here you can explore all the subgraphs that are on the decentralized network. Livepeer is one of these. We can look at a playground here, and in the same way that I showed you earlier, I can delete the existing query here, and I can construct my own query by using a simple checkbox style interface. I can look at the transactions, the gas price, gas use, ID, timestamp to, I don't know, this is getting quite a bit of entities, so you would usually limit it to however many that you need. And you can go on the Graph Explorer to explore these, or you can go on the hosted service where there's quite a few, 31,500 subgraphs that you can search in and use for your project. So is there any other questions? So, I mean, we still have a little bit of time. I can also mention one feature that is very useful that a lot of people are unaware about is what is called dynamic data sources or templates. And this allows, I can show it in the docs as well, this allows allow you to create a subgraph that automatically tracks new data sources as they are deployed. So this is very useful if you are working with a factory style contract, for example. And I can find it here, dynamic data sources. No, this is testing. So here you will find it, and the data source templates for the dynamically created contracts. This can also be very useful if you have a proxy type implementation where the implementation keeps changing, even though the APIs stays similar, because then you can use the same, you can preload your subgraph with the same API and or with that API and dynamically update and index a new implementation address. Another useful feature is reading data from IPFS. And this is also something that is currently only available on the hosted service. And it's called IPFS on Ethereum contracts. This is also very, very useful and can be used in a lot of ways if you need to store anything on chain and then fetch it in your subgraph, or store it on IPFS and then fetch it in your subgraph. So tutorial link, we do have quite a few. Yeah, so we have the official docs should be where you are going to should be your first place to look for things. But if you want a more thorough tutorial, you can go to codex.thegraph.com. This has a collection of all our workshops so far, and you can go to developer guides. Here you have something, you have on resources, you have hackathon workshops. There's quite a few. So I can link this one specifically on dynamic data sources. There's a developer highlights video that was created a while back. Yeah, I can probably Yeah, so this is the developer highlights video. There's 6 of these diving into some of the more advanced topics when it comes to subgraph development. Yeah, that's everything I had. So unless there's any more questions, I think we can round off here. Happy hacking, everybody.
Thank you, Ørjan, for coming in today. We really appreciate your time, and that was super interesting. I think we will wrap things up there. I'll just give you a chance to make any final closing comments, and then we'll wrap things up. We will wrap things up there. Thank you, Ørjan. Have a good day, everyone.